All right, we are continuing with sample spaces and probability, and we're on example 3, finding probabilities of complements. When two six-sided die are rolled, there are 36 possible outcomes as shown. Find the probability of each event. A part, the sum is not 6. B part, the sum is less than or equal to 9. All right, so you can see over on the right, there's a image here with all of the dice. So you can see that the first one is row 1 with all the 6 different numbers, and then 2 with 1 through 6, and then 3 with 1 through 6, and this gives you all the different possibilities for two six-sided dice. All right, so this is a good example of where we can use complements, because A part says the sum is not 6. So if we go through and find all the ones that are 6, and then we do 100% minus the probability of 6, then that would be the answer. So let's kind of look at this. Let's start by just circling the ones that are equal to 6. All right, so if we look, we scroll down through here, 1 and 5 is 6. And then 2 and 4 is 6, 3 and 3, 4 and 2, 5 and 1. And then 6 and 1 is 7, so all of these are going to be greater than that. So the probability, the sum is not 6. So we're going to look at this as 1 minus the probability of the sum of 6. All right, so that's going to be the same thing. So we're going to have 1 and then minus, you can see we circled 1, 2, 3, 4, 5 out of 36. So 5 out of 36 have a sum of 6. And we're looking for a sum is not 6. So you need to have a common denominator. So a common denominator would be 36 over 36, that's just 1, minus 5 over 36 equals 31 over 36. So if we're looking for the probability that the sum is not 6, it's going to be 31 over 36. So let's see what that is as a percent. Okay, that is about 86%. Which means this 5 over 36, the sum of 6, that means there's about 14% would have a sum of 6, and then 1 minus the 14% gives you the 86%. Again, that's the definition of complement. So these, the sum of 6, and the sum is not 6, those two would have to add up to be 1. B part, the sum is less than or equal to 9. All right, so I'm going to change to red. All right, so if the probability, we want the probability to be a sum less than or equal to 9. Less than or equal to 9. All right, so that's going to be, we can write that as a complement as well. So it can be 1 minus the probability of the sum. If this is the sum at less than or equal to 9, we need the probability of the sum greater than 9. All right, and again, the reason we do that is because it'll be easier to count up this number. Obviously, you could go through and just count all the ones that are less than or equal to 9, but you can see there's going to be a lot more of those to count. So this is just a kind of a quicker way to do it. So let's look at all the ones that are greater than 9. So if we have 6 and 1, that's 7. Here's 6 and 2 makes 8. So that means all of these in the first two columns are not going to be a sum greater than 9. So here is 6 and 3. 6 and 3 is equal to 9, not greater than 9. So that's actually not going to count either. And then, so let's go to the next column. So we have 6 and 4. 6 and 4 is 10. All right, so this one would be 9, but it's not greater than or equal to. So we just need greater than 9. So here we've got 5 and 6 makes 11. And here is 10. And then this one's back to 9, so that's not it. 6 and 6 is 12. 5 and 6 is 11. 6 and 4 is 10. And then that will be all of the ones because this is back to 9. So we can see 1, 2, 3, 4, 5, 6. So we're going to have 1 minus 6 over 36. And again, we can do common denominator, 36 over 36 minus 6 over 36 equals 30 over 36. And again, if we want to look at that as a percent, (30) divided by 36. That's going to be about 83%. Example 4, using area to find probabilities. So we mentioned something called geometric probabilities when we were talking about definitions, and that's when you're calculating a ratio of lengths, areas, or volumes. So this is going to fall under that definition. Example 4, you throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? All right, so the first thing we're going to do is looking at the probability of getting 10 points. So the probability of 10 points. All right, to get the probability of 10 points, we first need to find the area of the smallest square, the smallest circle, because you can see that 10 falls inside this smallest circle, and it has a radius of 3 inches. So it's showing us that the radius of this small circle is 3 inches. Remember that the area of a circle with the radius r is equal to area equals pi r squared. So that's something that we need to know. All right. So we're going to have to find the area of the small circle. So we're going to do pi times 3 squared. All right, now remember the probability goes over the whole. So now that we found the area of the small circle, now we're going to have to find the area of the entire board. So the area of the entire board, that's this dartboard right here. We can see that this is a radius of 3, 3, and 3. So 3, 6, 9. That means all the way across would be 18 inches. So this would be 18 inches. All right, and to find the area of a square is just side squared, or side times side. So this is going to be divided by 18 squared. All right, so we can simplify 3 squared is 9. So 9 pi over 18 squared is 324. And if we want to find an approximate probability of this, we can do that. So we're going to do 9 times pi divided by 324. And that's going to be about move 2 decimal places, that's about 8.7%. All right, so if you're throwing darts, landing on this 10-point section here, obviously if you practice, you should hit the center more, but if this says it's equally likely to hit any point, that means you have about 8.7% chance, if it's equally likely to hit anywhere, that you hit the 10-point area there. All right, now it says, are you more likely to hit 10 points or 0 points? So now we need to find the probability of 0 points. All right, so 0 points, you can see it's 5 points in the middle, 5, 2, and 0 is this outside edge here. So this one's going to be a little bit more tricky. How do we find the area of this outside the circle? It's inside the square, but outside the circle. So we're going to have to take the area of the square. So we're going to have 18 squared, because we already determined that the square 18 inches across, so side squared is that. And then we're going to take that and subtract the largest circle here. So the area of the circle again is minus, and then it's going to be pi times r squared. So the largest circle has a radius of 9. 3 times 3 here. So 9 squared. And then again, the probability is always over the whole. So that's going to be over 18 squared as well. All right, so if we do a little simplifying, 18 squared, we already know is 324. Minus 9 squared is 81. So it's going to be minus 81 pi over 324. All right, let's see what that gives us. So we've got, let's put this in parentheses. So we've got 324 minus 81 pi divided by 324. And the reason I put that in parentheses is because when you have this minus sign here, it might have just divided this last number if you don't put that in parentheses. So when you have division, to make sure your calculator knows all of that goes on top of the division sign, you have to put that in parentheses. So that's going to be about 0.215. And that's going to be about 21.5%. So because 21.5% is greater than 8.7%, this shows you that you are more likely to get a 0 points than you are 10 points. Again, hopefully you practice them, you get better at aiming, so that would change the scenario a little bit. But if, in this case, it says each point is equally likely to be hit, this would be the formula to figure out which one would be more likely to land on. And again, you'd be more likely to land on the 0. These outside portions here have a bigger area than this inside area here.